welcome back everyone, and thank you for the engagement in the last video. I certainly didn't expect the collimation of the Epsilon 180 ED to get so much engagement, but it's really appreciated that it did, and I certainly hope that it helps you out and that some of you are now able to get the most out of this telescope and get some great images in the near future. And I certainly would love to get the feedback from you that that is the case, that you're getting some great data of the night sky using your telescope now. Anyway, what's happening from an astronomical point of view? Well, June is a little bit of a blowout month from an astronomical point of view. As most of you know, approaching the equinox, the longest day, the 21st of June, you literally have no astronomical darkness, so I haven't been busy with anything. However, the new project is now started. It actually started Sunday, last Sunday that is, and we're just coming into a new weekend now, when I managed to get 45 minutes of data on M57, the Ring Nebula. And I'm just looking at the Ring Nebula now. Perhaps the most famous planetary nebula in the Northern Hemisphere, in the constellation of Lyra, between the two guide stars of Shellac and Sulfat, but the most prominent star there, of course, is Vega, shining bright. It's approaching the zenith at this moment, so it's a good opportunity to image it. Now, I have imaged M57 before, somewhat successfully. Probably the best image that I've taken of M57 was with my Mulan. The Takahashi Mulan is a Dal-Kirkham telescope. Dal-Kirkhams are so designed to give the best possible on-axis performance, but I do suffer from a little bit more coma. My Mulan was updated with the corrector baffle tube that Takahashi offered for these telescopes, so it is corrected. A corrected CDK would be the more modern term for it today. Even so, even with the reducer in place on the Mulan, the fastest it comes to is 7.8, and whilst my image of M57 is good, it didn't allow me to get the outer rows of the Ring Nebula. For those that you will know, and I'll put an insert in, it's very easy to image the ring, the central part of the ring itself, but it's much more difficult to image the outer, fainter rows, the outer shells of the nebula that we see perpendicular to us. Those are very difficult to image, especially when you're dealing with Bortle 4 to 5 skies, as I am here in the Netherlands. You need a lot of HA data to start to reveal that outer shell, and that's essentially the project that I'm taking on, to get that outer shell image. However, it's a two-part project. I've imaged the ring in the traditional way, so what I mean by that is I've imaged the Ring Nebula with LRGB in the traditional imaging way, where you would take 3, 2 or 5 minute subframes, stack them and generate an image of the Ring Nebula. So my plan this time around is to do some lucky imaging, and all this will be happening with the RC. The reason I'm choosing to use the RC for this project is because, of course, it's 14-inch, so the light gathering is far better than the Mulan, but also the speed of the RC is better, and I hope that will cut down the time required, or the integration time required, to get the outer shell of the Ring Nebula. Natively is f8. Now, f8 isn't that fast. In fact, it's slightly slower than the Mulan, as I just discussed with you. However, I have an astrophysics reducer in there which brings down the focal length of the RC and brings it to f6. Mine is about 5.8, 5.9, just under that f6 level, and I'm hoping that will help me to reveal the outer shell of the Ring Nebula. It's all collimated, it's all ready to go. We just need some clear skies, and that brings us to the weather. The weather in July has been, well, hit and miss would be the polite way to put it. We've had some brief clear spells, but not many of them. It's both been punctuated by a lot of rain and of course clouds, which doesn't help us at all as amateur astronomers. But this weekend, as I said, there's a chance for me to get more data over the weekend. There's a chance for me to gather more data this weekend. It's not totally clear, it would be partially cloudy, but you know how the weather show these with just one cloud rather than two clouds, so it looks like it's a possibility for me to get more data, and then I can show you exactly how far I've come with the outer ring. So I will get the outer shell of the ring using traditional imaging techniques, long exposures, integrating them and pulling that data, teasing that data out. The length of the integration time that's going to be required, I don't know right now. However, for the second part of the project, I want to do lucky imaging, as I said. The bigger challenge is the lucky imaging. It's a bigger challenge than I first realized. So my original idea was to use a planetary camera, my Neptune planetary imaging camera, the 664, because the file size from this is at least more manageable for lucky imaging. So why not a bigger camera? Well, to be frank with you all, my one-shot color camera that I have is this one. It's the TubeTech, and this is an APC size sensor. Yes, it can go fast enough to do the lucky imaging. However, every single frame that I would receive from this would be about 54 megabytes, which when you're trying to collect probably hundreds, let's say, or even a couple of hundred frames, that's a lot of data to store, especially then to stack that data. I certainly have no experience of that, so I may need to call on somebody's help or experience in stacking that data. I know a couple of people have a lot of success with Cyril in setting up stacking of potentially hundreds of files for lucky imaging. However, a club member, so a big thank you to Jan, made a suggestion to me which I hadn't really thought of myself, is to use the TubeTech, the APC one-shot color size sensor, and to use a region of interest. So therefore use a program like SharpCap or another suitable program like maybe Fire Capture. Select a region of interest, and that will help me to reduce and potentially reduce the file size and potentially make it more efficient in my stacking, in the final stacking of the image. Because what I want to try to do with the lucky imaging is to see just how far I can push the image details in the Ring Nebula. The details I have so far I'll show you in the images I've taken. They're pretty good, but you get a standard bow type look around the ring. However, they're not as detailed as some of the images that you can see online taken of the Ring Nebula. So I want to see how far I can push the detail of the Ring Nebula by using lucky imaging with the RC, and just how much data is needed to be collected with the RC to get the outer shell, and then to make a combined image of those two to produce hopefully what will be the final image I'll probably make, at least for now, of M57, the Ring Nebula. You can find M57 using various planetary programs. I like to use Stellarium. It's located between the guard stars of Sulfat and Shellac, but the main star that you see in the constellation Lyra is of course Vega, and I'll put that on the image screen now. And it's a beautiful nebula to image. However, if you do want to image this, I would suggest that you need at least a minimum focal length of around about 1200 millimeters, preferably a bit more. I will be imaging at just under 2 meters focal length, and with the Mulan, the image that you've seen already, that's my best image of M57, was taken at approximately 1800 millimeters, so a couple of hundred millimeters just under the 2 meter mark. It's really quite small, and if you do want to reveal the nice structure and detail of the ring, you do need a telescope with more reach. It's ideally suited for those of you with Schmidt Cassegrains. This is a great target for those telescopes. And with that, I'd like to wish you all success in imaging M57. It's a great target. It is relatively easy to do if you only want to image the ring itself. If you want to push yourself and try to get the outer shell and maybe do some lucky imaging like I am, it can be a great target for a project like this. So good luck. Please turn your Schmidt Cassegrain telescopes onto M57. Give it a try for yourself, and with that I'll bring the video to a close. Again, once again, thank you all for the engagement that you're giving my videos. Please like and subscribe and share the videos. Thank you. Bye for now.